section 9.6. Okay. And so this section is called Translate and Classify Conic Sections. So what I want to start with is let's review all of the different conic sections that we have and what their formulas are. So let me pop into Desmos. And give me just 1 second here. Grab this paper. Who can tell me off the top of their head what is the formula for a circle? I guess I should make it so I can see the chat. What is the formula for a circle? There we go, Anton. Hey, Otto. So if we have a circle, it's x squared plus y squared equals radius squared, right? And then our radius can be any number. So if you have a radius of 3, then obviously your circle has... Oh yeah, you're supposed to be able to see the screen. You don't see it, Aaliyah? All right, let me try to screen share again. Be a very unexciting... unexciting video. Did that work better? Awesome. Sorry about that. I don't know what I clicked. Okay, so let's just start with the circle since we're all, it's pretty easy to see. I think the formula is easy to see. You have an x squared and a y squared component, and then you have your radius squared. Remember, this has to do with the Pythagorean theorem. So if you took a right triangle and you drew it in your circle, then the x squared plus the y squared the x squared component plus the y squared component would give you the hypotenuse, which is the radius squared. So it has to do with right triangles and Pythagorean theorem, right? All right, so this circle, though, is... where's the center of the circle at? Where's the center of the circle? There we go, Aaliyah. It's at 0, 0. It's right in the center, right? What if I wanted to graph the circle not at 0, 0? That's what you guys were all hoping to know about, right? Whoa, what happens if it's not at the center? So what we're going to do, and this is going to happen with all 4 of our conic sections, is we are going to say, what if we move this circle, and instead of being centered at 0, 0, instead of being centered at the origin, we have it centered at some point that is h and k. I don't know why it's h and k and not h and j or j and k, but it's h and k, so at least it's in alphabetical order. So in order to transform this equation into an equation where the center is at hk, we have to shift the graph, right? So if we want to shift the x part, put that in there. If we want to shift the x part, instead of being at 0, 0, we want it to be at h. What we need to do is we need to take x and subtract it by some value h. Okay, and in this case, we'll make h equal to 2. Okay, so remember, this is inside your function. When you subtract, it shifts the graph to the right. Remember that? Okay, the y is a little bit different because we usually don't affect y, but how we are going to change the point of y is we're also going to subtract by some value, which is going to be k. Okay. Let's do this. All right, So this circle still has a radius of 0, still has a radius of 3, right? Here's the center of the circle, and its radius is 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? There's your circle radius of 3. The center of my circle, though, has been shifted from 0, 0 to x equals 1, 2, y equals 1, 2, 3, 4. So my new origin of my circle is at 2, 4. Okay. And I've done that. Over here, you see that an effective way of doing it is saying x minus 2 and y minus 4. That shifts the origin of my circle to the right and up. Okay. So instead, if I made my h value, -4, and my k value +4, then my new center of my circle is at -4, +4. That's where my new center is. Pretty cool, huh? I think it's cool. All right. So then if you're doing your homework and we do one of these examples here. So if you have your notes, there's actually a chart that shows the standard form of equations of translated conics. So what that basically means is that you're taking, your circle or parabola, ellipse, or hyperbola, and you're shifting it, because when we learned about all of these, we learned that they were at 0, 0, right? And so what happens if we want to shift our circle, shift our parabola, shift our ellipse? How does that look? Right. So example number 1 says, graph and identify the important characteristics of the conic section. So here we go. We're going to do number 1 since we're talking about circles right now. So we have x plus 1 squared, and I'm going to turn this off. X plus 1 squared plus y minus 3 squared equals 4. Okay, so I have this equation, and before I even turn on Desmos to tell me what this looks like, can you tell me what this is going to be? Is it going to be a circle, parabola, ellipse, or hyperbola? So what's this going to be? It's going to be a circle, parabola, ellipse, or hyperbola. Circle, right? This is going to be a circle. It looks just like this equation up here. So we know it's going to be a circle. Does anyone know, based off of looking at these two equations, right, what is the radius of my circle going to be? So equation's still the same, right? The radius squared is whatever is equal to, as long as you're in this format. So the radius of my circle is going to be 2, right? It's going to be 2. The radius squared is 4, but the radius is going to be 2. Okay. All right. So I've got that. But then where is my circle going to be centered at? So I know it's going to be a circle, right? X squared plus y squared equals 4. So it's going to be a circle with a radius of 2. Turn this guy off up here. But it got moved around, right? I have plus 1, x plus 1. So that's actually going to move my circle to the left by 1. And that's that weird thing. Remember, we've talked about this with all of our translations. When you move a graph, on when it's inside the function, it seems like the opposite sign. Like you feel like I'm adding +1, I should go to the right. But because of the way that functions work, right? When we add, it goes to the left, and when we subtract, it goes to the right. So my new center is going to be at -1, and I have y -3. And so since that's being subtracted, that's going to go up to +3. Okay, so I suspect that what's going to happen is my red circle is going to shift, and this is going to be my new center point right here. Okay, so let's see when I turn it on. My red circle shifted up, and this is my new center point at -1, +3. So if you are doing your homework, it says graph and identify the important characteristics. You would want to graph it. You would want to say that it's a circle, that the radius is 2, and that the new origin is at 1, 3. Okay, does everybody feel comfortable with that? Sorry. All right. Sounds good. All right, so guess what we're going to do? Now we're going to talk about the same thing, but we're going to talk about it for parabolas and ellipse and hyperbola. All right, so I'll just go ahead and put it out here. The general equation for a parabola, so remember this is like one of the first things that we did, was if it's a parabola on the we'll just do horizontal axis right now. If it's a parabola on the horizontal axis, it was y squared yeah, I guess we'll do this one. Y squared equals 4p times x. And then we need a value for p. Let's actually do the other parabola. Let's do the one that opens up like a normal parabola that we're used to. So let's change this to x squared equals 4py. Let's do that. All right. So remember how we talked about parabolas? This was, I think, back in 9.2. And we had this value here that is 4p. And then your p actually helps you calculate where your focus and your directrix are. All right, does everybody kind of remember that? I'm going to take that as a yes, right? You can solve, when you put your equation in this form, whatever p is, so 4 times p equals whatever value you have in your equation, and then p is your focus point. Right? All right, so this parabola, and actually the other parabola when it's shown the other way, all have their vertex at 0, 0. So what happens if we don't want our vertex to be at 0, 0? Well, we're going to do the same thing. So our new point, again, is going to be at some h and some k. It's going to be at some h and some k. Oh, we can make a point there. So let's say that our new point, we want to move our parabola so that the new vertex is at 3. We'll do 3, 4. It's where we want our new vertex to be. Okay. So what we need to do to our equation is we need to move the x. Oh, I don't want the parenthesis there. I want it here. Okay. Nope, don't want to do that. Undo. Can't get it to listen to me. Take this guy off here. So we want x minus whatever our h value is squared. Okay, so you can see when I put that h value in, it's pulling this h value from Desmos, and it automatically shifts it to the right by 3. Okay, to shift our y value, right, we want to do y minus our k value, which happens to be 4. So do you notice a pattern? Basically, every time we're going to take our original equation and we're going to move our point by subtracting the x by h in parentheses and the y by k. So that's nice that it's not like different for every single one, right? So you can see how your parabola gets moved over 3, 4. Let's go ahead and let me add one in here. Let me go ahead and put in the other parabola that goes the other way, just so you can see. Y and k and x and h. Okay, so the first one is, they're both blue. There we go. We'll change this one to red. All right, so the red parabola, right, is an example of one that has a vertical axis. And you can see how the graph has been shifted up to 3, 4. The blue parabola is one with a horizontal axis, and so you can see how that has been shifted over by 3, 4. Okay. So let's look at example number 2. It says graph and identify the important characteristics of your equation. So if I look at number 2 before I even put it into Desmos, can you tell me what kind of equation this looks like? Does this look like the equation of a circle, the equation of a parabola, an ellipse, or a hyperbola? So number 2 is, oops, let me draw through it. Number 2 is a parabola. I need to pick the right thing. Okay, number 2 is a parabola because look, it matches up with this equation right up here. Actually, it matches with this one. Okay, they look the same. So we know this is going to be a parabola. So before I even graph it, I know it's going to be a parabola. Okay, where is my new center? Where is my new vertex? Sorry, my new vertex of my parabola going to be at? Remember, the vertex or the center is going to be at HK. All right, so this is really just looking at it. In this, if I look at these two equations, H is equal to 2 and K is equal to -3. Can you see that? H is equal to 2, K is equal to -3, so that we can get that plus sign there. So my new vertex is at 2, -3. Okay. I also need to be able to tell where my focus point is. I guess let's double check ourselves real fast. Okay, so if I put this equation in there, let's get rid of all this stuff. I have x minus 2 squared equals 8 times y plus 3. All right, so it is a parabola, that's good. And my new vertex is at 2, -3. So I'm able to do that. Now, where is my focus point at? So this is going to take you back to 9.2. So it's kind of a review of 9.2. Where is my focus point at? Well, if I just had a regular parabola, right? If I had a regular parabola, my focus point, if my equation was x squared equals 4py, right? P is where my focus point is, and I set 4p equal to 8. So you guys should remember doing this, right? 4p equals 8, or p equals 2. So in a regular parabola without any shifting, right? Just following along? Where would my focus point be? It would be at 0, 2. Okay, so let me just visually show you this. If I took this parabola and I took off the shifting part, okay? If I just had this parabola, my focus point would be at 0, 2. It would be right here, right? But my graph has been shifted, and so it's shifted down here. So now my focus point is still 2 units up, but I'm starting at a different vertex. So what happens if I go from this vertex, I don't really want that to show you. I go from this vertex with the to 2, -3, and I move up 2 spots, 1, 2. Now my new, sorry, did I say that wrong? Oh yeah, I go from this vertex to find my focus, right? My new focus would be at 2, -1. So my new focus for this, my focus will be at 2, -1. So you can kind of visually see that in order to get my new focus point, I basically add my vertex and my original focus point together, and I get my new focus point. Okay? I know it's like a lot of information. Does it sort of make sense? Nobody's in the chat. You guys are all asleep. Would you like to see another example of how to do a parabola? Or do you think you got it? All right. I got 2, I got it. So I'm going to assume that everybody's got it. Okay. Next up, our friend the ellipse. Okay. So I'm going to go, I'm going to go horizontal ellipse. Okay. So let me write the equation of an ellipse, right? So we have x squared over divided by some a squared. That's totally not right. Should always look before you start typing. divided by a squared plus y squared divided by b squared equals 1. Oops. Well, that's okay. There we go. There we go. That's a nice looking ellipse. You can zoom in a little bit. All right, here's our ellipse. This is the regular equation for ellipse. Remember, ellipse is when you take a circle and you're going to stretch it. These points here are called the vertex, and those are controlled by this a squared value that's under your x. These points here are called the covertex, and they are kind of the secondary vertex, and they are controlled with the b squared term right here. So you can see that b is 2, b squared, and then you get vertex at 0, -2. The focus points for this ellipse are going to be somewhere along the horizontal axis because this is a horizontal ellipse. And the equation for finding those focus points is c squared equals a squared minus b squared. Okay, so now if I want to take this ellipse and I want to shift it, right? I want to shift it. The x is going to be shifted by h, so minus h. And the y is going to be shifted by k, minus k. Add sliders for those. And let's add one more point. Let's put in where h comma k is and label that. Okay, so if I move my new center of my ellipse, let's see, to -5, -3. I need to zoom out a little here, right? I do that by, my equation would look like x plus 5 and y plus 3 over my same a squared and b squared. What do you notice, though, happens to your vertices and covertices? See if I can get it to point there. Doesn't want to point to that point. All right, so let's look at a covertice, right? So your original equation is at 0, 2. Or sorry, your original covertex is at 0, 2. Your new covertex is at -5, 1. And we've shifted by -5, 3. So you can see what happens if you take the covertex and you add it to the shift, which is your h and your k, your new center, then you get the new covertex part. Okay, so for example, this is at 0, -2. I do 0, -2 plus negative, so for my x, I've got 0 plus -5. So this is going to be at -5. And then -3 plus -2 is -5. So this point should be at -5, -5. That's all because of the shifting. So it gets a little more complicated to figure out where vertex and covertices and the focus points are, but it's really not too bad. Okay. And I don't know why I can't get my vertex to pop up here. Oh, there we go. So if I have this, my vertex here is at -3, 0. My vertex here should be at, when you move your graph, it goes away, -3, 0. It should be at -3 plus -5, so -8, -3. -8, -3. All right, so the same thing will happen with your focus. If I found the focus points of this ellipse, then I have to shift them down to the ellipse here. All right, so let's do that. Let's do one like that. So let's do number 4. And there's me drawing on the screen again. Oh, not what I wanted to do. Just take that off the screen. There we go. All right, so I've got this equation. It's kind of small to see, right? It is x squared, or x minus 2 squared over 16 plus y minus 1 squared over 9 equals 1. So the first thing I have to do is I have to identify if this, and I cut off my things, this is horizontal or vertical. So I know this is an ellipse because I have the equation that equals 1 and I have a plus sign, right? I have a plus sign here and a plus sign here, and so I have a plus sign here. So I know it's an ellipse. If I had a negative, then it would be a hyperbola. Is it a horizontal or a vertical ellipse? Well, I know it's a horizontal ellipse because 16 is bigger than 9, so that means that's going to be my a squared that's going to drive this. All right? So what I like to do for these is I like to do, once I get to ellipse and hyperbola, okay, I like to take this equation and let's figure out everything without the shift. So without the shift, my equation would be x squared over 16 plus y squared, y, not j, y squared over 9 equals 1. So without shifting my graph, if I flip back in my notes to 9.4, right, this is going to be an ellipse with a horizontal axis. So my a squared equals 16 and b squared equals 9, which means a equals 4 and b equals 3. And my vertex is going to be at plus or minus 4, 0. I'm pulling this all from your notes 9.4. Remember how we did all this? See, here's your ellipse, here's the equation. Your vertex is going to be at plus or minus 4, 0, and your co-vertices are going to be at 0 plus or minus b. And I'll show you why we're going to do this in a second. So your co-vertex is going to be at 0 plus or minus 3. Right? And then the last thing that we need to find is our focus point. So again, if I go back to my notes, here they are. Your focus points are going to be at C0, where C squared equals A squared minus B squared. Okay. So we want to find our focus, our foci, right? Which is that C squared equals A squared minus B squared. Okay, C squared equals 16 minus 9, or C squared equals 7, or C equals the square root of 7. So your focus points are going to be at plus or minus the square root of 7, 0. So I realized I ran through that kind of quickly. That's what you should be working on in 9.4, right? When you do your 9.4 homework, hopefully you've done that. That's what 9.4 is about. Okay. Now, I'm going back to my original problem, right? My original problem, I have a x is subtracted by 2 and y is subtracted by 1. So that means that my new center, my new vertex, where I'm going about, instead of at 0, 0, has been shifted to 2, 1. Right? I get that because X minus 2 means that K equals 2. So it's a shift of 2 in the positive. And Y minus 1 means it's a shift of 1. Okay. Sorry. So then what I'm going to do is I'm going to take everything over here and I'm going to translate it. So my new vertex is going to be at when I have, let me kind of write this out here. If my vertex is at 4, 0, and I add 2, 1 to that, my new vertex is going to be at 6, 1, right? I also have a vertex at negative 4, 0, and I add that to 2, 1. And when I add that together, I get a vertex at negative 2, 1. That's where my new vertex are going to be. Okay. My new co-vertex, right? Before my co-vertex were, this is like my scratch work over here, we're at 0, 3. So I add 2, 1 to that. I add them together, and I have a new co-vertex at 2, 4. And then my other one was at 0, negative 3. And I add 2, 1 to that, and I get that my other vertex is at 2, negative 2. Almost there, right? Last one is my focus points. Where are my new focus points at? My foci, right? That's going to be, let's go ahead and change that to a decimal because we got the square root of 7. Square root of 7, 2.65. Okay. So I have a focus at 2.650, and I need to add that by 2, 1, because that's what I'm shifting. So my new focus points are at 4.651, and then I have a focus at negative 2.650, and I add that to 2, 1, and I get my other focus point is going to be at negative 0.651. Okay, so now how can I, double check that I did this right? It was like a whole bunch of math. You're like, whoa, came out of nowhere, right? How can I double check this? Desmos, of course, right? So let's put in our original problem, which is x minus 2 squared, not cubed. That's going to take us to a whole different thing. Divided by 16 plus y minus 1. Oh, goodness. What am I typing? Y minus 1 squared divided by 9 equals 1. All right. Well, that's a good sign. It's an ellipse, right? We said that the new center of our ellipse was at 2, 1. If I can type correctly. At 2, 1. So when I label that, that looks good. We said that the focus points, right, were at 6, 1 and negative 2, 1. So our focus points should be at, it doesn't like the equation. It's at 6, 1 and negative 2, 1. It's telling me undefined because of how it's graphing it, but you can see that that's points that are there. The co-vertex is at 2, 4 and 2, negative 2. So 2, 4 and 2, negative 2. And then your focus point should be at 4.651 and negative 0.651. So basically your focus points are like here and here. So now that we graphed it, we're able to see that we did that right. So can you see how basically what you need to do is solve without the translation and then make the translation to do that? All right. So last one is a hyperbola. Guess what? You're going to do the same thing that you just did with an ellipse, but we're going to throw a negative sign in there. Okay. So let's run through that really fast. I know it's like a lot of math, but let's kind of go through that just to make sure that you're all comfortable with that. Don't forget your hyperbola sheet here, right? Kind of helps us out. I want this. Okay. Again, not having good luck with selecting things today. Okay. Graph and identify important characteristics. So this is a hyperbola. I can tell you that because it equals 0, so it's either an ellipse or a hyperbola, and it has a minus sign right here. All right, so it's a hyperbola. If I look at my equations, right, can I tell if this is going to be a hyperbola with a horizontal axis or a vertical axis? What do you guys think? This one's going to be one. Yep. Aaliyah, you're right. It's going to be one with vertical, right? Because this 4 here is bigger than this. We can just assume that this is divided by 1. Ooh, divided by 1. Right? And so because this is bigger, it's going to be a vertical axis, right? Oh, wait. I just said that wrong, Aaliyah. I agreed with you, but I was saying that the opposite in my head. It's actually going to be horizontal because no. Sorry. I'm mixing up ellipse and hyperbola. It's going to be horizontal, but I thought you were right, Aaliyah. It's going to be horizontal because look at the format of it, right? This has an x squared first, or this x term is first, and the y term is getting subtracted. So it has to be a horizontal one because if it's vertical, then your y squared term is going to be first. Sorry, I was mixing up the ellipse rule and the hyperbola rule. So it's going to be a horizontal hyperbola because the x squared term is first and the y squared term is second. Sorry about that. Okay, so let's do the same thing where we make it an equation, but we take out all the extra stuff. So we've got x squared over 1 squared minus y squared over 4 equals 1. Okay. So now if it was me, I would flip back to my hyperbola page, right? And I say, okay, this is a horizontal equation. My vertices are at plus or minus a0. Okay. If I look at my equation, a squared is equal to 1, and a is equal to 1. So my vertices are at 1, 0, and negative 1, 0. Okay. My co-vertices, I feel like I'm going to run out of time here. My co-vertices are at 0 plus or minus b. So my co-vertices are at 0 plus or minus 2, because I get this from 4, right? And then the asymptote is going to be at y equals plus or minus b divided by a. So it's 2 divided by 1 or 2x. That's where your asymptote is going to be. Okay. All right. So my graph is going to shift by what? It's going to shift by -3 in the x and +4 in the y. So I get the -3 because it's whatever happened to my x term. It's the opposite of that. And the +4 because we're subtracting by 4. So then my new vertices are going to be at, basically it's going to be 1, 0 plus -3, 4. And I get -2, 4. All right. My other co-vertice is at -1, 0, -3, 4. So -4, 4. Right? My new co-vertex is going to be at, instead of 0, 2, we're going to shift it by -3, 4. So my new co-vertex is going to be at -3, and then 2 plus 4 is 6. And it's also going to be at -3, 2. That's where my new co-vertex is going to be. All right, what about my asymptote? Where's my asymptote going to be at? Actually, I don't have that written down. Well, let's graph it and let's see if we can figure out where our asymptote is at. Okay. So your equation is x minus 3 squared minus y minus 4 squared divided by 4 equals 1. Okay. So your new hyperbola, your new vertex should be at 2. Oh, did I do something wrong? You should have a vertice at 4, 4, and 2, 4. I did something wrong. What did I do wrong? Oh, this should be a plus. That helps if you write the equation right. Okay, your new vertices should be at -2, 4 and -4, 4. So that's good, right? And your co-vertex have moved up as well. I don't have it written down how we're going to shift our asymptote. I'm trying to remember off the top of my head. Let's see. Our original asymptote was at y equals 2x. I think I just need to subtract 3. No, add 3. Nope, that's not going to work. I got to do something to my asymptote to move it. Let me get back to you on Monday about how we're going to move our asymptote. However, I know this was an extremely long lesson, and it was very, very detailed. I think once you try it, you should be able to do it. Like I said, on Monday, I'll go over how we shift the asymptote. For some reason, I don't have that written down on my paper. But everything else you should be able to do, be able to move your equations. Like I said, I'm sorry that it was a very long, kind of dry message, but hopefully it makes sense that we're just basically moving things around by that H and K. So everybody try that out. On Monday, we'll finish chapter 9, most likely, because it's 9.7. So that means that their homework and test will be due fairly soon. So, all right, guys. Thanks for listening to me talk for like an hour. Sorry that was not as exciting as I could have made it, but thanks, guys. Bye.